All right, welcome guys to Mr. Brown's science class. Thanks for tuning in today. I have here my contact information. If you need to get a hold of me at some point with any questions about the class, feel free to give me a call on the phone number I've provided there with the extension. You can also reach me at any time on my email through my school account there. As far as today goes, we are going to talk about the difference between physical chemical changes and properties. So we're going to be looking at how you can determine them, what they are, as well as the four factors that affect them, and looking at how reactions actually occur, the products and reactants of those. Okay, are there any questions at this point? All right. So as far as physical chemical properties and changes go, we'll just jump right in, and as we go, we'll have a couple places where I have you guys kind of jump in with some answers for me. So looking at properties, by definition, properties, everything's going to have some form of properties. We're looking at two specific types when it comes to identifying chemicals and substances. Some may display just a couple. Others are going to have a ton of them that you're able to pick out pretty easily depending on what they are. What we're here to look at is kind of breaking down between the two and identifying what is a physical property versus a chemical property, and therefore how you're able to differentiate between the two. So as far as what is a property, they're displayed by all objects. A property can be defined as a characteristic or attribute possessed by all members of a class. So I like to break this down into pretty simple terms. It's pretty much how we're describing something. Some of these are going to be really easy to identify. Other ones are going to take a little bit of work. And you'll see how between the two types, physical and chemical properties, that can come into play. So the first ones I'd like to talk about are physical properties. And physical properties are exactly that. They are based around a physical identity of something. So they're ones that can be observed without changing the chemical identity of the substance. In this case, some examples, I have color, shape, hardness, and texture. So color is pretty obvious, shape as well. Hardness, you would have, usually you can test this on a hardness scale. It's used a lot in earth science. You can take a rock and scrape it against something to see if it is able to produce damage to that, and you're able to determine the hardness level of that substance. And lastly, the example there, I have texture. Once again, just a physical, you can look at this property without manipulating the actual substance other than picking it up or measuring it. Okay, so all of these can be measured, but you don't have to change the chemical identity. Okay, and that's kind of a key aspect here. As far as chemical properties go, you have a substance and you're looking at its ability to change into another substance. Okay, so a chemical property is one that can only be identified by changing it into something else. So it has to change for this to happen. So an example, flammability, which is the ability of something to burn. So the only way you can tell if something is flammable is to burn it. I can't look at a piece of paper and just assume it's going to be able to burn. Okay, toxicity level. Once again, to be able to determine the toxicity of something, you have to test it. Now, I wouldn't suggest doing that on yourself, but there's a lot of different ways that you can check for toxicity of different substances. Reactivity, the readiness of something to react with other chemicals. A good example that you guys may be very familiar with is baking soda and vinegar. So those two substances are extremely reactive. They're very willing to react with each other to form the stereotypical volcano from your childhood, where you have all the white foamy bubbles show up after you mix those two things together. And lastly, I have oxidation level. And oxidation level, in looking at a substance, it's really hard to determine that without changing the substance. It's impossible to. A good example would be the Statue of Liberty. So you have the Statue of Liberty, which is made out of copper, and that statue is or has oxidized over time. So instead of being the nice orangish brown metal color of copper. It's a greenish color from sitting out in the bay in New York, which is the oxidation level reacting with it. The only way you'd be able to determine that is to actually let the metal oxidize. So we have chemical and physical properties that we're going to look at. So here I have some practice with these. As far as these goes, I'd like to have each of you go through these. I'm going to just go through the list here, and I'd like to have you identify which way you think these different properties go. So in review, so physical, you don't need to change the substance. You can just identify it with tools in hand, whereas chemical properties, you're going to have to manipulate it in some way, change its identity. So Mr. Masson, if I could start with you, I have here the first selection that you have is hardness. So do you think that that would be physical or chemical? And if you just let me know, I can draw a line over to physical to kind of connect them.
Go with physical.
That is correct. So physical would be hardness. So you're going to be able to determine hardness without changing the identity of the substance. Okay. Mr. Telesco, if you could tell me color, what would you go for color?
Physical. Final answer.
Final answer. Nice. Okay. So physical, that is correct. Okay. Mr. Bittenbender.
Yes, sir.
Flammability.
That would be, I believe, chemical.
That is correct. You'd have to light the thing on fire to determine if it could actually burn. You can't look at a rock and just assume it will or will not burn. Okay. Mr. Masser, back to you. How about luster? Which don't know that terminology. Luster is kind of a weird word. You may not have come across that. That's going to be the shininess of something.
So that would be physical.
That is correct. Okay. Mr. Telesco, how about texture of an object?
Physical.
Physical, yes. Correct. Okay. Mr. Bittenbender, how about shape?
I believe that is also physical.
Correct. Okay, we have two left, and we only have one chemical, so we can kind of see where these are leading. But, Mr. Maston, reactivity?
Chemical.
Chemical, correct. And Mr. Telesco, toxicity?
Chemical.
Chemical, good, thank you. Okay, so notice if you look at these hardness, color, luster, texture, shape for physical, they're kind of pretty common properties that you can identify with something, whereas the other few, they're a little bit harder to recognize, and that is kind of within practice. Most of the time, physical properties are pretty easy to identify. All right, the next slide I have here, physical and chemical changes. So we looked at properties, so now we're going to look at changes, and they describe the object's ability to turn into something else. Okay, as far as physical changes go, just like their properties, they don't alter the chemical makeup. So an example I have is phase changes. When ice turns to water and water to steam, you're just changing the phase of what it looks like. Okay, chemical changes, on the other hand, you have to create a new substance. Okay, for instance, I have here burning an object. If you take a log and burn it on a campfire to test to see if it's going to be flammable. Okay? Once you burn it, you've created a new substance. You've created ash, you've created all the the smoke and different vapors that come out of it. So you're changing the actual identity of the substance. The other thing with chemical changes is they're a lot harder to get back. So you can't turn them back into their original substance. As far as some clues to finding these different reactions, there's a color change, a temperature change, or a new substance forming. So I have here a couple examples. The leaves in autumn, that's going to be a color change for a chemical reaction. A temperature change would be without a heat source, doing it on its own. That's a good indication of a chemical reaction. And then something new just out of the blue showing up, gas bubbles or precipitate, which is essentially, if you think of precipitate as precipitation rain in the form of a new substance, sometimes you'll see little white flecks show up inside of a mixture that you're making or something along those lines. Okay. As far as the next thing I'd like a little participation in, I have here some changes, and we'll kind of start from the bottom and go up this time. So what I'd like you to do is, if you could identify the different pictures here as a physical or a chemical change. So Mr. Bittenbender, if I could start with you, I have a rusting car. Do you think that's physical or chemical?
I believe it is a chemical change.
That's correct. Okay. Ice cubes melting. So you, Mr. Telesco, if you have ice cubes melting, it's still water. So what do you think there?
Physical.
Physical. Okay. Correct. Mr. Maston, I have a saw cutting through some wood there.
Physical?
Physical. Yep. Okay. This statue is a bronze statue that has a little bit of patina on it. So in other words, it's that color change like the Statue of Liberty. So Mr. Bittenbender, are you able to tell me for that one, is it chemical or physical?
I believe it's also chemical.
Correct. Okay. I have some bacon and eggs cooking here, Mr. Telesco. So what would you say?
That one's actually tough. I would, I guess, because they're burning, I would say chemical.
That is correct. Okay. Because can you uncook something? Once an egg goes from raw to cooked, can you get a raw egg back?
Why would you ever uncook bacon?
That is quite true. So I agree. Okay, so that would be chemical. And lastly, Mr. Maston, I have these orange crushed cans.
Physical?
That would be physical. Awesome. All right, well done. Okay, so last piece here is looking at the as far as the rate of chemical reactions. Okay, so for a reaction to take place, you have to have the particles come into contact with each other. So what we're going to look at is there's 4 factors that allow that to happen. I'm going to go through these pretty quick. So the 4 factors are concentration, surface area, temperature, and the presence of a catalyst. Okay, and we'll hit on these real quick. So as far as concentration goes, it's how much of the substance you have. So if you have a really big or high concentration, you're probably going to have a lot faster of a rate of reaction. As far as a low concentration, it's going to be much less. For surface area, if you have an increased surface area, you're going to have a higher rate. This is why, well, you tell me, why does sawdust burn faster than a log? Can somebody answer for me? How about Mr. Maston? Why would you think cutting up a log would make it burn faster?
Because it's not as, I guess, dense.
Right. Okay, good. So you instead of having one big chunk, okay, you have a whole bunch of little chunks that you can set on fire and therefore increase the amount that's reacting with the fire. Excellent. Okay. Next we have temperature. Okay, so the amount of heat present in a substance. Because of this, you're going to have a lot more particle movement, which means, you know, as you heat things up, the particles tend to move faster, which increases the rate of reaction. And lastly, a catalyst, and a catalyst is going to be a substance you're able to add to the chemical reaction to either speed it up or slow it down. Some of the things, you have a catalyst in your body, you have quite a few, but they're known as enzymes. Amylase is a good one. It's in your saliva. So it's kind of weird to think about, but as soon as you put, let's say, a potato chip in your mouth, your amylase that's in your saliva starts breaking it down. And that's why chewing and having saliva in your mouth is going to speed up your digestion process. Once again, there's enzymes in your stomach, but we use it to actually help us make food as well. Milk can have enzymes provided to it that will turn it into, what do you think would create, or what food would we eat that you think would be milk turning into something else? Mr. Telesco, do you have an idea?
Do you mean something like milk turning into like a
new edible food?
Like a sour cream, or
sour cream? Yeah, perfect. Okay, so that's a great example. Sour cream. It could even be yogurt. Any of those products are going to be a milk that has an enzyme added to it, which then increases that reaction. Okay. As far as the end of class here, what I have is an exit ticket that I'd like you to go through. This last question, because of time constraints, we're going to cut that off. But what I'd like you to do is for the next class, if you could submit to me through the online system, answer these 3 questions. I'm sorry, the numbering got a little wacky there, but just go ahead and answer them to the best of your ability. And then for the next class meeting, we'll start with these questions as our opener. Okay, does anybody have any questions before we end the session? All right, thanks so much for participating today, guys. I appreciate it. Have a good evening.